It is Wednesday. Good morning to you, to another edition of the Weather Academy. Craig and I were just discussing here. When does school actually? I mean, it's usually the first week of June.
Somewhere in there.
Somewhere in there. It's like the first week of June here. So, and we'll be mentioning why we even talked about that. We weren't bored. There was actually a reason that we did that.
Yeah. Well, why not? I mean, it's we'll tell you. It's you know, we're trying to plan out how we're going to do this through the rest of the school year. You know, Memorial Day week might be a little strange, but we'll cross that bridge when we get there. Bottom line is, as we go down or get down to the end of the school year, this might become a little bit more of a weekly thing,
right? As
opposed to 3 days a week.
Correct.
But anyway, we'll let you know. We'll let you know.
Well, lots of time for that.
Yeah.
Well, today we're talking kind of dovetailing. You'll find that some of what we talk about dovetail from things we talked about before, and we chat about air masses. Now we're going to delve a little bit deeper into air masses and how we use them.
Yeah, so this past Monday we finished up our talk on space, so we're going to bring it back down to Earth. Now there's a lot to get to here, so we're going to go ahead and start you off with kind of the basics of air masses and why they are important to us in the meteorological community, and how these air masses work and behave, and what separates these air masses.
Sure, absolutely. And what is an air mass? I mean, it's basically, we're going to use a very informal term here and say a blob, a large blob of air that typically stays over the same area for a very long period, or actually what we call a semi-permanent period. You know, they're, to a greater or lesser extent, these air masses stay over certain parts of the world, and they pick up the characteristics of that part of the world. For instance, you see that purple at the top there, that's right there at the North Pole. So air masses that hang in that area, you would expect to be cold, and while there is ocean there, it's mainly dry and ice, so it'll pick up cold and dry conditions. Where the green there at the bottom, the MT, that's over warm ocean, so you would expect air masses there to get the characteristics of warmth and humid conditions.
Yeah, so this is how we kind of break it down into types: maritime polar, maritime tropical, continental polar, continental tropical, and continental Arctic. And basically dovetailing, we'll use that word today, off of what Tom was just saying. What these air masses are they are regions or blobs of similar temperature, similar dew point, similar humidity, and these tend to move around, okay? And sometimes they do mix with each other, but eventually one of them has to win out.
Right.
You know, and how do we figure out what separates two air masses? Well, at the leading edge, there is a line of demarcation, if you will, that we call weather fronts. So we're going to delve into that. So that's kind of an overview of the types of air masses that we deal with. And in the wintertime, Tom and I were just talking before we came on the air, continental polar is usually pretty typical for us in the winter.
Absolutely.
But then in the summer...
In the summer, you know, summer, you know, lately it's been definitely not only the maritime tropical, that green in there, but we know we've had some what we call continental tropical. So again, just as a little aside here, you know, tropical doesn't necessarily mean humid all the time. Tropical is also a designation for anything that's warm. You know, the P, you know, for polar, and T for tropical are basically cool and warm. M, maritime, is generally humid. C, continental, it's over land, is generally dry. So that CP there, that dark blue right in the middle, that is usually that's probably the most common one that affects us in the wintertime, which makes sense. We're cold, and the lakes are what give us the snow a lot of times, but it generally is a dry air mass.
Yeah, and just another modifier to this before we move on. Kind of an easy way to think about this: if the word maritime is in front of either tropical or polar, it's usually over water. Maritime, ocean, think sailing, stuff like that. Continental, it's over land, okay? So that's kind of the qualifier there. So let's move on and kind of review about high and low pressure, because this is also important when it comes to air masses as well. And I'll take this one. So low pressure, remember, it's a counterclockwise circulation and up. That's how the wind flows around low pressure. High pressure?
High pressure, just basically the opposite. It's a clockwise circulation, and the air blows down into the center of a high. So those are the general circulations for high and low.
Yeah, and they tie into our air masses and our what we call sensible weather. So that's just kind of a quick review of how high and low pressure behave. So let's talk about fronts now. So we mentioned fronts that separate these air masses that we just discussed. So the first one, pretty common, that most people know, especially here in Erie, Pennsylvania, and really all across the Northeast, cold front. These are indicated on weather maps by a solid blue line with what almost look like teeth. They kind of can be mean sometimes. You know, they cop a little attitude in the summer with thunderstorms, and then in the winter with cold weather. So this denotes the location of a leading edge of a colder air mass that will displace a warm air mass. That's the technical definition. But keep in mind, as we talk about fronts, when we use the term warm and cold, those are relative terms. So you might be thinking to yourself, well, in the summertime when a cold front comes through and it's 95 and the temperature drops to 88 behind the cold front, that still classifies a cold front, okay? So just keep that in mind. Cold and warm are relative terms, okay?
That's right. And the other thing to keep in mind as well is fronts are determined by the movement of the cold air. Because cold air is dense. Cold air is basically the commander that decides how fronts will move. So as Craig just mentioned, cold fronts separate the cold air from the warm air. In this case, the cold air undercuts that warm air and moves it away. So it would be logical to think, well, warm front must be the warm air is pushing the cold air. No, that's not the case. The cold air retreats and the warm air takes over. So when warm air hits cold air, it can't push it because it's less dense. It's like having a big lineman in football with maybe confronting a ballerina, perhaps. The ballerina can't move the football player. So the ballerina is the warm air. The ballerina can go over the cold air, but it can't push it out. So warm front, the cold air is retreating and the warm air is taking over.
So basically we use the word displacing with the cold front. So with a warm front, the warm air is actually replacing a colder air mass. And I know that it's kind of small to see, so if you look right here, Tom, you can see it better.
Okay.
I know you don't have your glasses on
I
yet.
don't.
But anyway, that's kind of what warm fronts are. So it replaces the cold air mass. And these are typically located on the eastern edge of a low pressure system.
Right.
Which, if you were to look at a low pressure system on a weather map, the right side of the low is always the warmest, which is usually where you find the warm fronts.
Absolutely. And typically, do you want to go back to the low? Why don't you go back to the pressure
systems? Go back to the pressure systems. Let me go back up one more. There we go.
So keep it on here. And go ahead. There we go.
Yeah.
He's got the long arms there. So when you look at the low pressure, on the right side of the low, you can see with the circulation, the right side of the low, the winds are south. And south winds tend to be warm, so it's going to move the warm air northward while the cold air retreats. So if you go on the other side of that low, now you're on the northwest flow. That brings in the cold air, as he's showing. So your cold fronts tend to be to the left of the lows. Now when you go to high pressure, typically you don't see fronts with high pressure because fronts tend to be areas of low pressure. But high pressure can influence the cold air. High pressure is just the reverse. If you go on the right side of the high, now you got the northerly winds. That's going to help funnel that cold air into the low. While on the left side of the high, we have some warmer air, southerly winds. So right side of lows, left side of highs are the warm side. Left side of lows, right side of highs tend to be the cold tend to be the cold side.
I don't know if I did that well.
You
I
did
feel
that
like,
well.
I feel
was
like,
impressed.
Catholic school.
Yeah. I was ready to chat some more, man. You're just having way too much fun with that. Good for you.
So that's the review of where the fronts are. Now there's a couple more fronts we have to get to. Tom, stationary front?
Stationary front. Go ahead and pop it up full screen there. Stationary fronts, as the name implies, are fronts that are relatively stationary. Now, it is a bit of a misnomer because fronts are never totally still.
Right.
They do,
Kind of oscillate.
Right, they'll meander a little bit, but a stationary front, typically if a front moves, say, and this is an arbitrary number, but say if it moves like less than 25 to 50 miles either way, you could call that a stationary front. Stationary fronts, typically, we don't think of them at the surface, at first glance as being very, as having bad weather. But a lot of times when fronts don't move, you can get what we call, and we've mentioned this for training, where storms form along the front and keep forming along the front and move along that front.
Yeah.
So if it keeps happening over and over in the same area, we do worry about flooding with stationary.
Yeah, so basically think of a stationary front as a set of train tracks. That's kind of the path that storms have to go along. And these fronts can be, they can have pretty stark contrasts on either side in terms of temperature and air mass. So if you're on the, basically what's happened here, you can come back to us. If you have, imagine, like, here's your stationary front, my hand. The air masses are perpendicular to that front. They're coming at each other. So on this side of the stationary front, it could be 70, 75, 80. And then on the colder side of the front, it could be 40, 50, 55. So there's quite the difference there with the air masses going perpendicular in that stationary front right down the middle. That, if you remember when we talked about low pressure and how they form, temperature difference, okay? That's usually where you get the clashing air masses, and that air has to go up, which then it condenses into clouds and wet weather. So stationary fronts can give us fits when it comes to forecasting weather.
They really can, and oftentimes your low pressures will actually form initially on stationary fronts, and that's when you start to get that separation with the warm front on the right side of the low and the cold front on the left.
Yeah, and it can be really, it can wreak havoc on a forecast because if there's a stationary front that's splitting the area in half, you literally could get away with forecasting 50 degrees to 80 degrees, depending on which side of the front you're on.
Absolutely. And we can get that on a smaller scale a lot, even at this time of year,
with the
lake breeze. And while it's not really the focus of our discussion today, the lake breeze is literally a mini cold front formed by the lake. When we talk about fronts, we talk about what we call the synoptic scale. That's a large scale covering hundreds and thousands of miles. But we have a smaller scale called mesoscale, which covers 10 to 100 miles. And that's where those little mini lake fronts happen. And how often has it happened where it's 50 along the lake shore and 75 in Edinburgh?
Yeah.
We see that all the time.
All the time.
Especially this time of year.
Yeah, and I'll just dovetail off of that too. So we started off our discussion about air masses. That would be an example of a synoptic feature, okay, because they're large, where the lake breeze is tiny compared to an air mass. All right, let's talk about occluded fronts. Now, this is represented by a pink line on the weather map, or fuchsia, I guess, maybe.
Mauve, perhaps.
Yeah, maybe.
Kind of a purplish.
Purplish.
Pink, yeah.
It's got semicircles and what are called pips, which are the teeth-looking things on there. This is basically when a cold front, so a cold front can move pretty fast, okay? And sometimes what happens is these cold fronts will actually catch up to the warm front. Well, then what happens? Well, that's when you get what's called an occluded front. And as this happens, the warm air rises and forms that occlusion. This is typical with mature, low-pressure systems. Now, just because of physics alone, storms here on Earth can only get so strong, okay? They have to go through each phase of their life cycle. So eventually, the storm will just get so strong that it has to just peter itself out. And usually you see an occlusion with a mature or strong area of low pressure or a dying low pressure system.
Occlusion is, the occlusion process is usually the beginning of the end for a low pressure. Once it occludes, basically, it's where you can come back to us, Cindy. Basically, the warm air is really where the energy comes from. And if you move that all the way off the ground, the low doesn't have its energy source. So as you just said, it starts to fill in, and that's usually the demise of the low.
Yep. So let's take a look at a couple of other graphics here that we've put together. And we'll kind of go over these real quick. This is what we call a surface weather model. We use these all the time, daily, 24 hours a day in the weather department here, and kind of a funky looking thing.
It really is. But, we have to look at data, wind, temperature, dew point, pressure, all in a very small area. So the Weather Service came up with what I think is a very efficient way of packing in a lot of weather data on one symbol.
Right. So you can see the circle there in the center, which would represent the sky cover. So when it's not filled in, that means it's clear or sunny. And then off of the circle, you have a line with two kind of dash marks. That is wind speed in knots and wind direction. So wind speed, that half dash mark that you see there, I believe is 5 knots. And then the one step up from that would be 10 knots. And then eventually they would fill it in with a flag, which I believe is 50 knots.
Once it gets to 50 knots.
And then you can see there's also temperature on the upper left-hand corner. Those 3 dots there indicate what it's doing, what the weather's doing. So is it raining? Is it snowing? In this case, that would be a symbol for moderate rain.
Moderate rain.
And then right below those 3 dots, you have the dew point temperature. We mentioned sky cover, and sometimes you see what the pressure trend is doing, which is that -6 with that little kind of doohickey thing next to it. It kind of indicates what the pressure is doing. Is it rising? Is it falling? Is it steady? And then that 107 that you see right above it is the sea level pressure. It's the actual barometric pressure, and then that little doohickey there below it, technical term, right?
Yes, I like it.
Indicates what that pressure is doing. Is it rising or falling? So obviously if low pressure is approaching, that would be falling. If high pressure is approaching, it would be rising. So that's kind of a snapshot of a surface weather model. You can find all of these at the National Weather Service website, or there's a really cool website called RAP, Real-Time Weather, which you can plot these on the map, and you can take a look at what they look like in real time.
Yeah, absolutely. Very interesting. And the type of weather, this is just a small, there's over 100 symbols.
Yeah.
Yeah, most of the time it's precipitation, rain, snow, thunderstorms. The technical definition of it is what obscures the visibility. Now rain, when it rains, it can lower the visibility, and snow as well, drizzle. But also you can get fog, smoke, haze, volcanic ash.
Oh, yeah.
We have sand storm. I mean, that's why there's a symbol for almost every single way that you can block the sunshine with these weather symbols.
Yeah, and just hop on the National Weather Service website, or just Google NCEP, NCEP, NOAA, and you can get a list of all of these. They have this really cool online learning portal called the Jetstream, and you can learn all about these symbols and then look at them, actually look at them on a station plot, so you'll be able to see how that looks in real time. And this is just kind of a quick sampling as we finish up here. This is an actual surface map, again, from the National Oceanic and Atmospheric Administration. Believe it or not, I did this, probably not to the extent that Tom did, but when I was in college, we actually had to draw where the fronts were on the maps. Much more involved, I'm sure, when you were in school. Now we have computers that do that, but that's kind of an example of what what it looks like.
It took a long, you get to be very adept at drawing after a while.
Sure.
But but that's what we use, and I know it might be a little hard to see, but we do have the low. Right in the middle of the map is a low, and the blue there, that blue line going, hopefully you know your state, south toward Kansas and Texas is the cold front, and from Iowa to close to Erie, okay, and the warm front is near us right now. That's why we're getting a few showers here. That red with the half semicircles or half circles are the warm front.
Yep. So that's kind of a view of kind of inside what we look at in terms of forecasting weather and how it all kind of comes together. So that, again, you can find all of this information. Just Google the National Weather Service. Look for the online learning portal called Jetstream. Really cool stuff. If you really want to delve into what we look at on a daily basis, and those station models, especially those ASOS stations, which Automated Surface Observation Stations, you can get a whole viewpoint of those from across the country and try and pick out where low pressure and high pressure is based on how those wind barbs are in formation around those weather systems.
It's a lot of fun.
Yeah.
Give it a shot.
Yeah.
Give it a shot.
Just get ready to squint a lot.
Yeah. Yeah.
They are tiny, but it's fun. All right, let's wrap it up. I knew this was going to be a beefy topic. We kind of threw a lot at you. If you have any questions, just shoot us an email, weather@WJET.TV, and of course, don't forget, we're always looking for that inspiration, okay? So it can be whatever you want. So hopefully you're finding out some cool things about weather, and if weather's not your thing, maybe the planets are, maybe biology, whatever it is, you want to learn more about it.
That's right. And that's it. That's our Weather Academy for today. Now, beginning Friday, Craig is going to take a day off. My cohort, Mr. Atkins, and I will be on Friday. We're going to go through some of the bigger, we're going to do a little history for you on some of the bigger weather events that have taken place here in Erie, going back really from World War II and going to some of the more modern days. We'll be doing this, the plan is to do it every Friday through the month of May. We'll go through different ones here, and you know, so hopefully you can look forward to that. Tom is, the man has...
Yeah, he's like our resident historian.
He is. I was born and raised here, and he knows more about the weather than I do.
Just, and that's going to be really geared, because I know that we, you know, a quick shout out to some of the people who are older that are watching, adults. I think you'll really like that. You will, and it'll, for some of you, you may have lived through it. I've lived through most of them. Of course, I wasn't here in World War II, okay, but my father-in-law was, and you'll learn what he had to deal with when he decided to come home on break. Let's just say he had an incredible, good timing when it came to some good snow. So until that Friday, for Craig and I, thank you so much for joining us. Have yourselves a great day. See ya.